Hi, my name's Alvin Crosby. I've been invited here today by Nahaya to talk to you about water. Now, I've been researching water for about 20 odd years now, so I have a fair understanding of what holds water together. What I have discovered is it's the most mysterious of all substances on the earth. First of all, I'd like to cover basic water chemistry. Now, we all perceive water as H2O, but in actual fact it's far from it. And the reason why I say that is because that it's made up of hydrogen and oxygen in various forms. Now, if we look at the hydrogen side of it, there are three isotopes of hydrogen. We have protium, deuterium, and tritium. Now, protium's abundant around us. In the air we breathe, the water we drink. It's the most common element of hydrogen in drinking water. So let's move on to the oxygen. And the oxygen exists in six stable forms. Oxygen 16, 18, 17, and I believe 19, and they've also discovered 20 and 22. So we'll stay with the six. Now when we mix those two together in a matrix, we get a 3:6 matrix. So that gives us 18 forms of water. Now if you can visualize that H1, which is protium, H2, which is deuterium, and H3, which is tritium. Now let's look at what deuterium is. Deuterium is what makes up heavy water. Now, heavy water is found in small concentrations in lake waters, in the sea, and in rainwater, up to 200 parts per million. The third isotope, which is tritium, is found in parts per billion and is very rare. However, the rareness of tritium enables us today to determine the ages of wines, for example, and various other liquids such as spring waters that come from deep within the earth. We can age them. So bearing in mind that we have H1, 2 and 3, and we have the oxygen isotopes, which I've mentioned before, the simple H2O molecule can have an H1 and an H3 and any one of the O's. Now that's significant because the human body can't process very well heavy water. And when I say that, this leads to what we call hydration. Now someone who drinks heavy water unwittingly wouldn't know any difference between say tap water and heavy water, and therefore the cells would not allow the H2 hydrogen ion into it. So it would simply just close the doors and dry up, shrivel up, and the person would die within days. Tritium, drinking tritium would have much the same effect on the human body. However, through various studies, the human body requires some heavy water and some tritium. Now, for example, ordinary tap water has 200 parts per million of heavy water in it naturally anyway, because in New Zealand we drink generally rainwater. So the higher altitudes where the cosmic rays bombard the water molecule and fragments it, deuterium and tritium is produced quite naturally in our upper atmosphere. Whereas spring waters have less of that. So you could say spring waters are better to drink just for that reason only. Now, if we go back to that matrix, apart from the 18 stable waters, we have what's called hydroxyl ions. Now, the hydroxyl ions are made up of the oxygen isotopes as well, the six that we spoke about, and also the hydrogen ions. So we have various combinations there as well. And let's not forget the free ions, which are oxygen and hydrogen once again. Now, if we add all those up, we get 35 stable waters. And that kind of changes our perspective on what water is all about. Now what I'm talking about here is pure water. In other words, there are no minerals attached to the water molecule at this point. Now the science of water is very complicated in the point of view that there are more than 200 anomalies with water itself. And we take it for granted. But when we think about how long it takes to boil a jug of water or a pot of water on the stove, we realize that it takes a lot of energy to bring it to the boil. Now that's an unusual state for hydrogen and oxygen in that combination. Hydrogen and oxygen is the most abundant of all substances in the universe. And of course the Hubble telescope have taught us, I suppose, that water is not just something we find on planet Earth. It's found throughout the universe. That we know that for a fact. Of course, water sustains all life. Without water, we have no life. So the Creator has created something very, very special. And I would say that's the reason why water doesn't come apart very easily. Getting back to the role that water plays in the human body, we also believe that when we drink water, it passes through us. But in actual fact, the human body breaks it down into hydrogen and oxygen, and this is why water, the quality of water, is so important to the function of the human body. The water is broken down by the energy which is in the human body, and then it attaches to substances, elements in the body, various pollutants, good and bad, and then reforms and then recreates water inside in the bladder is where it finally winds up, and then goes out as a pollutant. So the quality of water is very, very important. The poorer the quality of water, the less energy is imparted to the human body, and it will start to become sluggish. The cells will start to block up, and death will result from that bad quality of water. So what makes water impart the best possible energies to the human body? The various qualities of water that are therapeutic to the human body are those waters which are created in most natural environments, such as spring water, mountain, stream water. And the reasons why is because of the intrinsic charge that builds up, that nature induces through various forms. Flow, there's the geomagnetic field of the Earth, and you have your cosmic influences as well, from sun, moon, and further afield. These are all imparted into water through its flow, and we've all noticed how water flows. It doesn't like flowing in a straight line. It likes to move in a more like a snake-like fashion. And this is mainly due to the geomagnetic influences, which are counter in relation to the Earth's rotation. The flow is at right angles to that flow. So without this built-up charge, water would actually become quite dead and absolutely useless to life itself. One process that is imparted into water is the electrical charge, which we call ionization. This adds energy to the water. And the electrical charge is built up by minerals which are dissolved in the water initially, and these charges are built up just like little torch batteries. Now, how does that affect the human body? Well, when we take water into the body, either by drinking it, these little microscopic charges are then transferred into the cells. Thus recharges various organs and keeps us in the state of the alive feeling that we all love to have. The other way is to impart it into the body artificially, and the way we do that is by polarizing water with two charges, positive and negative. Now if we incorporate this simple mechanism, positive and negative charge, into a bath, for example, we can then cause a ionization of the water, thereby causing a minute splitting of the hydrogen and oxygen, releasing ions of oxygen and hydrogen. Now, by doing that, the human body will absorb high quantities of oxygen into the bloodstream, which has a tremendous effect on the properties in the blood, oxidizing impurities and also adding the life charge to the bioenergetic system. The hydrogen ions also have an effect on the cells, and the hydrogen ions relate to the body's pH, and also, as I said before, what we call hydroxyl ions. And the hydrogen actually has a higher role to play in maintaining the life force within the cells, and maintains the electron transport mechanism at the cell wall, and thereby maintaining the quality of water within the cell itself, so that the cell actually breathes. Now, it was once said that if we could maintain the purity of water within the cell would actually live forever, and I think that's been done at a laboratory level. The name Linus Pauling comes to mind there, for those of you who'd like to research that further.